Hi, in this video we're going to talk about addition reactions to double bonds, for multiple bonds actually, double and triple bond. So in our first example here, we have an alkene. You can see this double bond right here. If we had to name this, let's see now, 1, 2, 3, 4, 5. It's obviously a pentene, and we need the double bond as low in number as possible. So we'll number from this side, 1, 2, 3, 4, and 5. So the double bond begins on the second carbon. So this is going to be a 2-pentene. And what configuration? We know that when we have a double bond, we're going to have either a cis or a trans configuration. And as we can see, the backbone sits on both sides of the double bond, so this is going to be a cis 2-pentene. Alright, so here we go. We have this reacting with hydrogen. We have platinum here. Platinum is the catalyst. Hydrogen is the reactant. And what's going to happen is the platinum is going to grab this pi bond, this second bond between the second and third carbons, and it's going to break that. And hydrogen is going to add to either side of the bond. So we end up with, after the reaction, this is where the double bond used to be. Okay, so here we have 1, 2, 3, 4, 5. We now have a pentane, and we can just draw this as a straight chain. It doesn't need to look all crooked like it did here with the trigonal planar geometry as that double bond. This is just pentane. All right, let's move on to number 2. We have a similar situation here. We have a catalyst, and that's showing at the bottom. We're showing you different ways you can see this. If the reactant is actually shown in the lead to the left of the arrow, you'll see then the catalyst above the arrow. However, if you see the reactant of not in to the left of the arrow, not with the other reactants, but above the arrow, then that's telling you that's in the presence of. And at the bottom is where we put the catalyst. It can be somewhat confusing, but we want to show you where to find all this information depending on how you might see it. So taking a look here, we have 1, 2, 3, 4. We have a 4-carbon chain. So this must be a butene. We start here and count from the left to right. The double bond is not going to have the lowest number possible. So we count from the right. And this is going to be a 1-butene. Now, if we're going to break this double bond here, the catalyst is going to grab onto that pi bond, and then hydrogen can insert on either side of this, and we're going to form a butane. And as you can see, we'll have an H there, we'll have an H there, and we will X out one of those bonds, just like we did with the first one. All right, let's scroll down and take a look at some other examples here of these addition to multiple bonds. All right, a triple bond here. Okay, so this is an ine. We have a butene here. And if we count 1, 2, 3, 4, 1, 2, 3, 4, well, since it's in the center, it doesn't matter what direction we count from. And since there are no other functional groups on this structure, the priority isn't given to either side, so we can just count from left to right, 1, 2, 3, 4. Now, just in the last example, as you could see, we have 2 hydrogen molecules reacting here. We have nickel as a catalyst. And we obviously are going to break both of these pi bonds, the second and the third of the triple bond, in order to add the hydrogens here. So we're going to break 1, 2 of these, and 1 hydrogen will add and the other hydrogen we'll add. And in so doing, again, we form butane, just like we did in the previous example. Now, halogens will add and react just like the hydrogen does in the previous examples. Okay, but unlike hydrogen, we're actually adding halogens, so we're going to have some naming issues. Well, not issues necessarily, but we're going to have to name them and remember the rules for doing so. So, just like with hydrogen, in this reaction, the halogen diatomic molecule is going to break. That second of the double bond is going to break, and each bromine is going to add to each carbon on either side. What do we have here? What hydrocarbon do we have here? Obviously, it's an ene. It is 3 carbons, so it's a propene. We'll start from the right and count left to give us the lowest number, so this is just propene. Now think about it. If we had the double bond here, it's just going to be 1 propene. So really, we don't need to write the 1 because it's understood, because no matter what side we're going to put it on, it's still going to always be 1 propene. So it's just propene. Alright, so when we add bromine, it reacts and it breaks that double bond, and each bromine atom adds to either side of the double bond, giving us a structure such as this. Alright, and what will we name this? Well, we have the backbone, pro. This is an ane now because it's all single bonds. We have 2 bromines, so this is going to be a dibromopropane, and these 2 bromines are on carbon 1 and carbon 2. We can name them here. If we flip it the other way, it's going to be 2 and 3, and that's not the lowest number possible. So we have 1,2-dibromopropane. Now let's take a look at this last example under this addition little tutorial. We have 1, 2, 3, 4, 5, 6. We have a hexene here. Here's our double bond. In trying to number this, 1, 2, 3, 4, 5, 6. So that would be a double bond on 4, 5, or numbering from here, 1, 2, 3, 4, 5, 6. So obviously we want to number from the left. So that ene is going to be on the second carbon. And what else? Well, this is a trans configuration because the chain ends up on either side of this double bond. So unlike our last example, this is trans 2-hexene. Just like bromine, chlorine is going to come in here and it's going to add on either side of this double bond at the 2 and the 3rd position. So let's rewrite it here. And this is the second one where we added the first chlorine and we added the second chlorine. And now we have the entire molecule, 1, 2, 3, 4, 5, 6. We didn't lose any carbon, should still be hex. This time it's hexane. And we counted from the left before to give the double bond the lowest number. And since the chlorine atoms added to those same lowest numbers, we're probably going to have the same numeric convention here. This is going to be 1, this is going to be 2, 3, 4, 5, 6. And now the name. We have 2 chlorines, dichloro, and they are on 2 and 3, 2,3-dichlorohexane. So what you need to see is when we are either having a catalyst, and this is a hydrogenation, we're adding hydrogen to the hydrocarbon. When we have a catalyst that can grab onto that double bond, the double bond or triple bond. In the case of example 3, those pi bonds will break, and hydrogen will add to either, or the carbon on either side for each of those multiple bonds. For halogens, they will break the bond naturally. We don't have catalysts here, and they will add then onto either side of that double or the triple bond, giving us, in all cases, anes. Notice pentane, butane, butane, propane, hexane. So we're going to go from enes and ines to anes. And in the example of hydrogenation, we're just going to simple anes. But in halogenation, we have to remember that these are still important. They're a part of the name, and we need to make sure that we're giving them the lowest number for the halogens, so that we can get the appropriate IUPAC name.